So question 2. We are interested in the probabilities of ACT scores, and we're saying that ACT scores are normally distributed with a mean of 26 and variance of 16. Okay. So x, just call it x, is normally distributed with a mean of 26. Okay, now so the question gives you variance, okay? So is variance the thing that we want in this little, right here? No, actually we want the standard deviation. So the square root of variance equals the standard deviation. Okay? Sorry. So this is the value that we want. So we want the square root of 16 equals 4. Okay, so we put a 4 right there. Okay, this is more useful to us because we're going to be calculating some z statistics which involve the standard deviations. Okay, so part A. Okay, so we want the probability x is less than 26. Okay? Okay, so remember, okay, so the technique that I always use, and you may not believe me, but it's true, is I always draw out the normal distribution because I find that it's easy to visualize, easier to visualize when I actually have the normal curve right there. Okay, so we know it's centered at 26. Okay, and now the answer to this question actually follows immediately from this simple drawing. Now remember that the normal distribution is completely symmetric about the mean. Okay, what does that mean? If I folded this in half, it would fold in half exactly, and there would be equal parts on both sides. There'd be no extra parts on this side or on this side. Okay, so what does that mean for us? It means that there's an exactly even amount of probability on this side than on this side. Okay, or half of the probability is on this side and half is on this side. Okay, so what's the probability of x being less than 26? I don't have to look that up because I know the probability of being less than 26 is the exact same thing as being greater than 26, which is exactly 50%. Okay. And interestingly enough, part B is also the probability of being greater than 26, which is equivalent to 0.5 as well. All right. Okay, so this is actually part A, B/A. All right. Okay, so I'll write it up again. Let's see. Part C. Okay, so now we're interested in the probability of x being greater than 35. Okay, now we're actually going to have to do some math for this one. So we're going to draw out a normal curve again. Mean at 26. Okay, now recall the z formula. Okay, what this does is it exactly tells you how many standard deviations away the observation you're interested in is from the mean of the normal standard, or how many standard deviations away your observation is 35 from the mean of the normal of x, which is 26. Okay, so the equation is x minus mu, which is the population mean, divided by sigma, which is the population standard deviation. Okay, so we have both of these components. Actually, we have all of them. So we're going to plug it in. We're going to find z is 35 minus 26 over sigma, which is 4. Okay, and this equals 9 over 4, which equals 2.25. Okay? Okay, so this is an important thing to know. This is not a probability, okay? Your z-score, which is what this is never a probability, okay? This is a means of finding a probability, okay? This is the 2.25 is the amount of standard deviations that, so The amount of standard deviations, 35 is away from 26. So if this is 1 sigma, so this is 30. This is 2 sigma, which is 34. And then 35 is right here. Okay? So this is a total of 2.25 standard deviations away from the mean. Okay? So what does that mean? So we're going to look up, so we're going to have our z chart, okay? We're going to have z, our z values. Okay, this is going to be, etc. It starts at probably 3.5, 3.6, or 3.4, all the way down to 2.2. Okay, so this is the first and second place, like decimal place of the number, and then this column, these columns, this first column, and the columns afterward are the third decimal place. So you're going to do 0.00, 0.01, 0.02, 0.03, 0.04, 0.05. Now it goes on till 0.09, but I'm not going to draw that. Okay, so we're going to go downward. What I always do, draw a line, nope. And this is where we find our z value, okay? And this, inside the table is the probabilities. These are the z values, okay? So, in fact, 2.25 leads us to the z value of, let's see, 9, give me 1 second. 0.9878. Okay, 0.9878. Okay? Is this, now, okay, you think, okay, so is this the value, the probability that we want? Is the probability of getting greater than 35, 99%? Now, you may think intuitively that that's wrong because it's a large amount of standard deviations to the right, and that's a huge probability. That means it's basically assured that you're going to get a 35, and as you may or may not know, getting a 35 on the ACT is that's a high ACT score, so that's unlikely. So, okay, so you should remember that in general, the z table that they give you in your book, let's erase this too, is set up like this. Okay, it gives you a z value, and then you're getting the less than. The value is less than that, okay? But we don't want that. We want this value, okay? We want this. Okay? So what do? There are two options for this. Okay? We can do 1 minus this value, do 1 minus 0.9978, and get 0.0122. Or because the curve is symmetric, if this is z and we want this value, we can do 1 minus this value, or we could go to negative z and realize that this value right here is also the exact same thing. These are equivalent, these areas right here, okay? And think about this, we want this value, okay? So all we need to do is look up negative z, which is also on your table, and it'll give us the actual probability. So if we go to the negative z values, okay, the slight alteration, look up negative 2.25, which is right here, it would give us 0.0122, which is exactly the same as this value. You can check it yourself. It's totally right. So those are two alternative ways of doing it. I prefer the negative z value way of doing it. It's easier for me. I don't have to subtract anything. I always mess that up. Not saying you will, but this is one thing that will reduce your error. Okay, so that's the right answer. So, okay, so part D. Okay, so yes, that's the answer. Okay, Okay, so now we're interested in the probability of x equaling 36. Yeah, which is a perfect score. So what's the probability of getting exactly 36? And this is kind of a silly question, and it's not silly. It's silly because they don't really explain why it is, and it's kind of useless information. That's not my job to say it is or it's not. But due to the fact that statistics is derived from calculus, the probability of getting exactly anything is 0. Okay? So the probability of getting x equaling anything is 0, no matter what. If x is 5, probability of getting x is 922, 0. Probability of getting x is infinity, 0. Okay, so, and this is because you can only find probabilities in a range of values, and that's about all they tell you. That's about all I can tell you. Just know that. And the reason I gave you this question was because they may or may not trick you or try to trick you, and a lot of times they will try to trick you. So if they do that, now you have the tools to say that that probability is indeed 0. Okay, yeah, so, yes, okay. So one final part on question 2, E, probability that 22x 30. Okay, so there are two different ways to do this. There's a quicker way, and then there's a slower way, but both are equally equivalent. Okay, so I'll start out with the slow way and move on to the fast way. It's a horrible normal distribution. Apologize for my bad drawings. Okay, so 26 is the mean. We have 30. We have 22. Okay. Okay. So we want the value, the probability of being less than 30 and greater than 22. So we want. Okay. So the way you could do this by reading your z table is notice that the probability of being less than 30 is exactly this. So this is the probability of being less than 30. Okay? And then the probability of being less than 22 is this thing. Okay? So notice that we have what we want, except we double counted this. Okay? So in order to take that out, in order to subtract that, we find the probability of x is less than 30, and we subtract the probability of x is less than 22. Okay? Now, what this turns out to be, if you look at both these values in your table, this turns out to be, but all you have to do is just by looking in the z table, this turns out to be 0.68, give or take a little bit higher or lower. Okay, so that's how you do it. To find the middle area, you take probably less than this one minus the probably less than this one. All right, so let's see. Okay, so now there's an easier way to do this. Okay, and you should always try to check this to see if you can pull this off. As it just makes the computations easier. Okay, so notice what you have to notice is that 26 and 30 differ by 4. Okay, so 30 minus 26 equals 4. Okay, and also 22 minus 26 equals negative 4. Okay. Okay, so now I'm going to redraw this. Actually, I'm going to do the z-test on both of these first. So 30 minus 26, over 4 equals 1. And 22 minus 26 over 4 also equals negative 1, okay? Okay, so now we draw out the normal, the standard normal, and what we found was a z-value of 1 and negative 1. Okay? Now, something that you should always remember, something called the empirical rule, okay? What the empirical rule says is that if you look at a standard normal and you look at one standard deviation, you're going to find that 68% of the probability is within one standard deviation on both sides of 0. So from negative 1 to 1, there's 68% of the probability. Okay? Now, in 2 standard deviations, or 4 total, 2 on each side, there's 95% total. So this whole area is 95%. Okay, and with 6 total, or 3 on each side, there are a total of 99.7%, okay, of the probability. Okay, so this is something you should remember. It's useful, but the most important thing is that, remember, 30 and 22 are both one standard deviation away from 0, which is the mean for a standard normal, which is the normally distributed 0, 1, right? So, okay, so really, we already know the answer, okay? It's a little hidden by various colors now, but it is, in fact, 68%, just like our other answer. So it's the exact same thing. So whenever you can do this, you really should, because it's much quicker. So, but both methods work. And sometimes you won't be able to use the empirical rule, so in that case, you just do this number minus the mean divided by the standard deviation, and subtract that from this number minus the mean over the standard deviation, like we do in all the other things. All right, okay. And that's the end of question 2.